All right, let's do today's daily. Range sum of sorted subarray sums. This is a very wonky sounding puzzle. So I'm going in fairly blind. I've just read it and it seemed like something I could do. Um, so we'll see if I can do it. If I can't, well, whatever. You are given the array nums consisting of n positive integers. You computed the sum of all non-empty continuous subarrays from the array and then sorted them in non-decreasing order, creating a new array of n times n plus 1 divided by 2 numbers. Return the sum of the numbers from index left to index right, inclusive, in the new array. Since the new answer can be a huge number, return it modulo 10 to the 9 plus 7. Wow. So this is a very wordy puzzle. But for example, all the subarray sums are, so we have 1, then we can do 1 plus 2 equals 3, then we can 1 plus 2 plus 3 equals 6, then we can do 1 plus 2 plus 3 plus 4 is 10, then we can go 2 plus 3, 2 plus 4, yeah, and so on. And then we sort that, and then we get the, I don't know why it's 1 indexed, but we sort it from, so then we add from left to right, so 1 through 5, so 1, 2, 3, 4, 5, we get 1 plus 2 plus 3 plus 3 plus 4. Okay, let's do this. So I thought that this was going to be a matter of like figuring out a way that we can skip any step, because it feels like a lot of calculations. So I thought, is there some way that we can like, just figure out only the additions that we need to make? But that I couldn't really think of anything, and so I looked at the hints and it just said compute all sums and save it in an array, then just go from left to right index and calculate answers. So I thought there was going to be a cute solution that would be like some sort of math way to figure out the smallest, like the subarrays sums and like what they would be for a given range, but I don't think that you can. Or if you can, I don't know if it's much faster. At least the hint says to not worry about it. So we'll make it and see if we can, yeah. So first, let's make we're going to make subarray sums, okay? So we're just iterating through all the possible subarrays. Okay, now how do we make subarray sums? Well, it would be, it's probably a cool way we can do this. It would be sum of nums I let's see, I'm trying to figure out a cute way to do this. It'd be sum of nums I. It'd be sum of nums I through you know what, maybe there's not a cute one line way to do this. Okay, I'll just do subarray sums. I feel like there is a cute way of doing this, but I feel like it's just not worth the thought. I was thinking that maybe you could do like, like a one line thing of saying sum for I in this, but since we kind of had to like worry about two pointers being the first index and the second index, I think it's just going to be easier to do two loops. So for start index in range nums, and then for end index in range, and then we're actually just going to start it at start index. We don't have to, it's not going to be like start index plus 1 because we can have a subarray of just 1. Start index to nums, actually it'd be nums length. And we don't have to do -1 because it's not inclusive. Okay. Subarray sums dot append sum nums start index through end index plus 1 because it's non-inclusive splicing. Okay. Now we sort it. Can I just do that, or do I need to say subarray sums equals sort subarray sums? Oh, okay, so I do dot sort. Okay. Okay. And now I return the sum of the we're gonna do -1 since for some reason it's indexed 1, and then we can just, so we're gonna do left -1, and we're gonna do right. It's just right because it's non-inclusive. It's exclusive for the upper bound. So we're gonna do subarray left -1 right modulo 10 to the 9 plus 7. This, I would be very happy if this worked first try, but I don't know. No. Oh, yep, subarray sums, not subarray. Oh, I'm not paying you money. Okay, so it worked for that. Let's see if it works for all of them. I hope so. Okay. Maybe people did find out a way that, let's see, 40. Okay, so mine took a while. Did okay on memory. 46% of people did it in a fifth of the time. So maybe there is a way that we can skip a step and never like using a nested loop. I don't know how we wouldn't use a nested loop because you have to like get every possible permutation, right? Okay, well this person also used a nested loop. Oh, yeah, that makes sense. Okay, so another example where I did it right, but I learned a way to do it even better. And this solution saves a big cost because basically it keeps a tally. Well, it keeps a count, and then every single time it changes the end index, it it adds that sum. Because like basically this, I'm recalculating the sum every time. So I'm like doing 1 plus 2, 1 plus 2 plus 3, 1 plus 2 plus 3 plus 4. What they're doing is saying 1 plus 2 and then hold on to that 3 and enter that and then say, yeah, okay, so that makes sense. I'm going to do Subarray sum equals 0. Yeah, actually, other than that, it's exactly the same. um, oh, unsupported operand type. Let's see. Oh, because I appended Subarray sums, not Subarray sum. That's why you don't do variable names that are that similar. There you go. Way better. Okay, so another valuable lesson learned about it wasn't like a clever look at the question. It was just a much mine was doing way more work than necessary because it was not taking advantage of the fact that we just added together most of those numbers. So we don't need to, we could just tack on one more number instead of adding them all together once more. All right, that was a good one. Yeah, thanks for watching.